In today MT5506L practical based on mathematical programming, we are starting the practical number 10. First problem, problems based on BGAM and two-phase method. Let the problem be maximize z is equals to minus 4x1 minus 2x2 subject to constraints 3x1 plus x2 greater than or equals to 27, x1 plus x2 greater than or equals to 21, x1 plus 2x2 greater than or equals to 30, x1 and x2 are greater than or equals to 0. So first of all, the standard form of this problem is obtained by adding the surplus variables, that is maximize z is equals to minus 4x1 minus 2x2 subject to constraints 3x1 plus x2 minus s1 is equals to 27, x1 plus x2 minus s2 is 21, x1 plus 2x2 minus x3 is equals to 30, x1, x2, x3, s1, s2 and s3 are greater than or equals to 0. So if from here if itself we start this problem, then if x1, x2 and x3 is 0, then s1 is minus 27, s2 is minus 21 and s3 is minus 30, which is not a feasible solution. So we will add artificial variable. We have maximize z is equals to minus 4x1 minus x2, then already that 0s1 plus 0s2 plus 0s3 is there, subject to constraints. In each constraint we are required to insert artificial variable because everywhere we are getting negative values. So 3x1 plus x2 minus s1 plus a1 is equals to 27. From the second constraint we are having x1 plus x2 minus s2 plus a2 is equals to 21. Then x1 plus 2x2 minus s3 plus a3 is equals to 30. Your x1, x2, x3, s1, s2, s3, a1, a2 and a3 all are greater than or equals to 0. Here in objective function is maximizing function, so we will introduce minus m a, minus m b, minus m minus m a1, minus m a2 and minus m a3 in our objective function because the coefficient of artificial variable is large m. Okay, so we are having total, see, x3 is not there, so here x3 is 0 is not there and x3 greater than or equal to 0 is also not there. So we are having the initial basic feasible solution is a1 is equals to 27, a2 is equals to 21, a3 is equals to 30 with x1, x2, s1, s2, s3 all are 0. So in basis right now we are having a1, a2 and a3, so we will write the corresponding simplex table using that. So the simplex table is CB, B, SB, x1, x2, s1, s2, s3, a1, a2 and a3. the coefficients are -4, -1, 0, 0, 0, -m, and -m. Here in basis we are having A1, A2 and A3. Coefficients are -m, -m, and -m. Value of them are 27, 21 and 30. Now write down from the constraint. So we are having 3, 1, -1, 0, 0, 1, 0, 0, 1, 1, 0, 1, -1, 0, 0, 1, 0. And from the third constraint we are having 1, 2, 0, 0, -1, 0, 0, 1. So this is your first simplex table. Now we evaluate ZJs. So ZJs is -m times 3, -m times 1, and -m times 1. So it is 5. So -5m. Similarly here it is -4m. Here it is m. Here it is m. Here it is also m. Here it is -m, -m, and -m. Cj minus Zj is -5m. Cj is -4 plus 5m. Here it is -1 plus 4m. Here it is -m, -m. Here it will be 0, 0, 0. So maximum value is 5m because m is too much large. So 5 times m is larger than 4 times m. So this quantity is larger. So corresponding variable x1 will enter a basis. Now we have to evaluate which variable will leave a basis. For that we have to evaluate replacement ratio, that is 27 by 3 to 9, 21 by 1, so it is 21, 30 by 1, it is 30. So minimum value is 9, so corresponding variable A1 will leave a basis. So we are having this as a key element, and this entries we have to make 0. So first of all we will divide the first row by 3 and then we will subtract it from second and third row. So the our table is CB, B, XB, X1, X2, S1, S2, S3. Now A1 is removed, so we will not calculate the table for A1, so we will not write that, and A2 and A3. Coefficients are -4, -1, 0, 0, 0, -m, and -m. So here A1 is replaced by X1. To make this entry 1, we will divide everything by 3. So here it will be 9, 1, 1 by 3, -1 by 3, 0, 0. This is not there, so 0, 0. Now to make this entry and this entry 0, first of all in basis we are having A2 and A3. Coefficients are here -4, -m, and -m. So the basis, to make this entry 0, we will subtract from this row. So 21 minus 9, it is 12. Here it will be 0. Here it will be 2 by 3, because 0 minus 1 by 3. So it is minus 1 by 3. 1 minus 1 by 3. So here it is 2 by 3. Here 1 by 3. And then here it is -1. Here it is 0. This is not calculated. So here it will be 1. And here it will be 0. Now to make this entry 0, we have to again subtract from that. So 30 minus 9, it is 21. Then here it will be 0. Here it will be 5 by 3. Here it will be 1 by 3. Here it will be 0, -1. And this is not going to calculation, and 0 and 1. Okay, now again evaluate ZJ. So here it is -4 times 1, it is -4, -4 times, here it is 4, -4 by 3, -2 by 3m plus 5 by 3m, so 5 plus 7 by 3 m. Here it is 4 by 3 minus 2 by 3 m. Here it is minus m. So it is m. Here it is m. Here it is minus m and minus m. So Zj minus Cj is minus 4 minus 4 is 0, minus 1 minus this is 4 by 3 plus 7 by 3 m. Here it is 4 by 3, sorry, Cj minus here. This is okay. This is 4 by 3 minus, sorry, so minus 4 by 3 plus 2 by 3 m. Here it is minus m, 0, 0. So maximum value is 7 by 3 m because m is too much large. So this variable will enter a basis. Now to find out which variable will leave a basis, find out replacement ratio, that is 9 by 1 by 3, it is 27. Here it is 12 by 2 by 3, so 36 by 2. Here it is 21 by 5 by 3, so 63 by 5. So what is the minimum number? Here it will be 18 and here it will be less than 12. Okay, so approximately 12. So here this will enter a basis. Sorry, this will leave a basis. So A3 will leave a basis. So this entry is a key element. So you have to make this entry 1 and this entry you have to make 0. So the next table again is CB, B, XB, X1, X2, S1, S2. A3 is removed. Okay, so we will not calculate for A3 now. Sorry, A2 will be there only. Coefficients are minus 4, minus 1, 0, 0, 0, minus m. In basis now we are having x1, a2 and a3 is replaced by x2. Now to make this entry, let me write first of all coefficient minus 4, minus m, minus 1. To make this entry 1 we have to divide everything by 5 by 3. So our table will be, here it will be 63 by 5. Here it will be 0, here it will be 1, here it will be 1 by 5, here it will be 0, here it is minus 3 by 5 and here it will be 3 by 5. Now to make this entry is 0, we have to multiply this by 2 by 3 and add it here. So we are having 18 by 5, here it is 0, 0, 1 by 5, minus 1, 2 by 5 and minus 2 by 5. Here to make this entry 0, we have to multiply with minus 1 by 3 and add up there. So here it is 24 by 5, here it is 1, 0, minus 2 by 5, 0, 1 by 5 and minus 1 by 5. So now which variable will enter the basis? Sorry, I have made mistake. In S2 I have calculated in S3. Here it will be 1 only. Sorry. Here it will be 1, 0, 0 because it is not going to be changed. Okay, so now we evaluate Zj. So the Zj's are minus 4 times 1, so it is minus 4, minus 1 times 1, it is minus 1, minus 4 times 2 by 3, so it is 8 by, 5 and minus m by 5 and plus 1 by 5, sorry, minus 1 by 5. Here it is m, here it is minus 4 times minus 4 by 5 Here it will be minus 2m by 5. Here it will be plus 12 by, plus 3 by 5. Here it is minus m. Cj minus Zj, minus 4 minus 4 is 0, minus 1 minus 1 is 0. Here whatever it is, that is Cj minus Zj, so it is something m by 5 plus or minus some constant, that is a real number. Here it will be minus m, here it will be 2 by 5m plus or minus some constant, and here it will be 0. So m is too much large, so 2 by m is much larger. 2 by 5m is larger than 1 by 5m. So corresponding variable will enter a basis. Now we evaluate replacement ratio. So which variable will leave a basis, that we can identify. 24 by 5 by 1 by 5 it is 24. 18 by 5 by 2 by 5 it is 9. 63 by 5 by minus 3 by 5, so it is negative, so infinite, so minimum value is 9. So corresponding variable A2 will leave a basis, and this S3 will enter a basis. So we are having this as a key element, so we have to make that entry 1, and we have to make this and this be 0. So for doing that, again we have to evaluate the next table: CB, B, XB, X1, X2, S1, S2 and S3. Now A2 is leaving basis, so there is no need to calculate the table for A2. Okay. So we are having in basis X1, S3 and X2. Coefficients are minus 4, minus 1. Here it is 0. Minus 4, minus 1, 0, 0, 0. Now to make this entry 1, we have to divide everything by 2 by 5. So here it will be 9. Here it will be 0, 0, 1 by 2, minus 5 by 2, 1. To make this entry 0, we have to multiply this by 1 by 5 and subtract here. So we are having here it will be 3, 1, 0, 1 by 2, 1 by 2 and 0. And here to make this entry 0, we have to multiply with this by 3 by 5 and add here. So we are having 18, 0, 1, 1 by 2, minus 3 by 2 and 0. So this is our another simplex table. Now again evaluate Zj, that is minus 4 times 4, it is minus 4, minus 1 times 1, it is minus 1. Here it will be 4 by 2 plus minus 1 by 2. Here it is 4 by 2 minus 4 by 2 plus 3 by 2, and here it is 0. Cj minus Zj is 4 minus 4 minus minus 4 is 0, minus 1 minus minus 1 is 0. Here it is 3 by 2, and that is 0 minus 3 by 2 is minus 3 by 2. Here it is minus 1 by 2, minus 4 by 2 plus 3 by 2. So it is minus 1 by 2. Sorry, in everywhere here it is coefficient is 2. So this will be 2. Actually, because of that there is nothing changed, so no problem up to here, because that X2 calculation was coming from here. Okay. But up to this m was contributing too much, so no problem. But now here Zj value will be changed. Here it will be minus 2 times 2, it is minus 2. Minus 1 times 2, it is minus 2. Minus 2 times 1 by 2, it is minus 2 by 2. Here it is minus 2 times this is minus plus 3, and here it will be 0. So here minus 2 by 2, it is minus 2 by 2, it is minus means 1, Here it is 3 by 2, so minus 6 by 2, so minus 2 by 2, and that is again minus 1, and here it is 0. So all Cj minus Zj's are coming here less than or equals to 0. So this is your optimal solution. So the optimal value of Z is attained at x1 is equals to 3, x2 is equals to 18, with value of Z is equals to minus 4x1 minus 2x2, that is minus 4, x1 is 3 and minus 2, x2 is 18, that is minus 12, 36, so minus 48. So this is our optimal solution. Okay, we will do the another problem in next lecture. So stay at home and stay safe.